Okay, so fans and thermals. You're gonna have to forgive me. There's not an easy way for me to show you everything I'm going to show you, keeping this camera on a tripod, so there might be a little bit of movement in here. But we went with 120 millimeter fans for pretty much the entirety of this build by Noctua, and there's a couple of reasons for that. One, despite the fact that the 9000D is this really big, spacious intake, it could fit a lot of different kinds of fans on there. It's surprisingly more limited than you would think that it is. If you look at this top bar here, you'll see these gradients, and you'll notice that it is 240 millimeters wide. That means just about anything you decide to do on this rack, other than slot 120 millimeter fans right next to each other, you're going to have room. You're going to have all these like spare little gaps. It's also 480 millimeters tall. So again, anything that you do other than slotting 120s, you're going to wind up with extra space. So we went with the 120s just because we wanted to be able to fully utilize the extent of the intake. In the particular case of the Noctuas, we went with them just because they've got a great reputation for being super, super quiet and handling static pretty darn well. Despite the fact that we've got this big wide rail on the 9000D Corsair, when you mess around with it and when you start slotting fans into place, you start realizing there's kind of this invisible math of you're sacrificing utilization of the space when you use other fans other than the 120 millimeter wall. You'll see that in promotional literature for the 9000D. You'll see tons of pictures with it where it's essentially set up just like this. And you think, oh, well, that's cool, but I would pick bigger fans, or I would do it differently. There's a reason why it's set up the way it's set up, is because that's actually the optimal utilization of the space by simple math and division. So with that, let's get around to cabling in the back here and how some of these things are set up. Okay. So all these individual fans, pretty straightforward. You saw on the other side, we just got these screws. We just screw them into place on individual brackets. And every single one of them is just going to come with a little power cord like this. And they're also going to come with handy dandy splice kits. So you'll see in this particular case, we've got two cords and they're going into one connector. Now, the fan headers for our particular board can handle up to 36 watts of power draw. Each one of these fans is 1.8 watts peak. So that means essentially we could load 20 fans into this thing, wire them all together, and then just put them onto one header, and we still wouldn't get into trouble. So our real goal here is to just take as many of these cords that are coming out of the fans as possible and connecting them together so we minimize them down. Two becomes one. Then we get another connection where two becomes one. Then we take those four between those, hook them together again, that becomes one. And then we're going to fish them all back here and get them all connected, and then we're going to run them to a fan header. That's our fans, pretty straightforward. We made a couple of other decisions in our thermals. You'll notice we've got 8 fans on this front intake. We wanted to fully utilize that space. For our exhaust, we've got these 4 guys on the top of the chassis, and we've got these 2 guys in back. So we essentially get this wall of air, 8 fans that are all just pushing air directly into this big cavity of our 9000D chassis. And then we've got 6 fans that are working to pull that air back out. And that's going to give us a slight pressure differential. It's going to give us a slightly positive pressure in the chassis. And the advantage of that is exfiltration versus infiltration of air. If I've got a positive chassis, every exposed point, every place where there's a potential air gap, air is going to want to push out of the chassis. And if I've got a negative pressure differential, or I've got a chassis that's in a negative pressure, then every exposed gap is going to be a place where essentially unfiltered air could enter into the equation, dust, lint particles, things like that, sneaking its way into our machine. So as much as possible, we're looking for positive pressurization here. For fan headers, we connected our fan header. See if you can see it here. Right here on the board. It's this little plug. It's hiding kind of right next to our DIMM tray. And there's a very good reason for that. When we slot our GPUs, we're trying to get them very bottommost slot and very topmost slot. There's a bunch of fan headers that run along this lower bar here. But if you use them as plugs on this particular board, then this GPU isn't going to slot. It'll just bang into them and it's not going to click into place. So again, that's where our really forgiving power tolerance on our fan headers comes into play. Is we can kind of just route all of this stuff to the fan header that's most convenient. In this particular case, it was this guy, out of the way of our GPUs, rated for 36 watts. We've got 15 fans in this case, so we're way inside that, and that's providing all of our power. Now, for CPU cooler, just since we're in here and while we're getting into it, we've got our 8 fans coming in, we've got 6 fans coming out, and we decided to go air-cooled for the CPU cooler. There's a lot of debate on this. You could go AIO with a pump, but there's a couple of reasons why we chose air-cooled in this particular case. Reason number one for air-cooled is this particular board, this setup, it's a server setup and a server board. This board doesn't actually natively detect the temperatures of our GPUs. It detects the temperature of the CPU and the temperature of the board itself. And it's going to use that to drive fan behavior. And even if you go into BIOS, there's actually no settings for like GPU fans. It doesn't even expose CPU fan curves. It expects you to manage all of this. So one thing we found pretty early on was if we installed an AIO here, and then let's say we slotted it for like our intake or something like that to keep the CPU cool, it actually did too good of a job. It kept the CPU really, really cool, and because the CPU was really, really cool, the other fans didn't respond to the temperatures that were happening inside the space as aggressively as they should have when the GPUs were ramping up. By switching to an air-cooled cooler for the CPU, we gain the benefit of exposing the CPU a little bit to the hot air of the exhaust of the GPUs, which essentially makes it so this board will ramp up when our GPUs ramp up, and it'll ramp the fans up when our GPUs ramp up, and it'll make it so everything essentially works in terms of the thermals without having to do all kinds of crazy reverse engineering on the setup. The other nice thing about it is you'll notice like the air pathways here. We've got a big fan wall coming in. Slide that into place so you can kind of visualize it. And we've got all this air that's just coming into this unit as like this giant wall. It's coming across and it's going through these GPUs and cutting across sideways. It's going up between this cooler and this GPU, air traveling sideways, trying to exhaust out here. And this cooler actually does a really, really great job of pulling air up from the GPUs and kind of stuffing it up through that exhaust fan up there. It rejects heat really, really, really well. We've tested this setup at this point. I did a 20-minute burn on the GPUs at full 600 watts. So 1200 watts of heat pumping out of both of these guys at full power with the CPU running. And we were able to stay stable roughly around 90 degrees Celsius after a full 20-minute run, which for that kind of power, those kinds of thermals is really pretty wild. We removed the bottom fan from this cooler, and there's a good reason for that. The top fan is oriented, so it's pointing at this upwards exhaust. The air leaves here straight up, and it pulls through this fan up into these exhaust fans. The bottom fan was oriented where it essentially pointed down. So if I had both fans on here, one of them would be trying to kick down in the direction of the GPUs, kind of against the orientation where they're trying to move air upwards. So believe it or not, having just that one top fan set up with the heat exchanger is doing us a world of good. So this is the fan setup. We've got 8 120 millimeter fans on the intake. We've got 4 dedicated exhausts, and I would count the fan on this CPU cooler as essentially like a 5th exhaust, since it's taking air from inside the case and literally launching it up at the exhaust fans. It's definitely empowering exhaust with what it's doing. So slightly positive pressurization, pretty balanced case. The CPU is exposed to the thermals of the GPUs, but that's actually doing us a lot of favors in our engineering and setup. And we've ran this thing for 20 minutes straight in a test, loading up both GPUs at 600 watts. And it stabilized right around 90 C, and it could just throw air all day. It does not care. It just rejects heat, and finds a really nice point of stabilization. That whole time, the CPU is never getting above maybe 92 degrees C, which is still well inside of its comfort zone. And that's our setup, and that's what we got going on here. So no AIO, 100% air cooled. We're running everything through, really 2 fan headers. We've got a CPU fan header, and then we've got this header for the rest of the fans. And this thing's really, really kicking butt in terms of thermals, and it's crazy quiet. I can ramp this thing up at 1600 watt full draw, have it really, really cranking, and it's quiet. It throws heat really, really, really well, and spent a couple of days getting to this point. If you see over here to my left, the part of things that you don't see is a big pile of fans and all kinds of different things that I was trying in the setup to optimize it and get it right. You can see over here, I've got a really nice AIO cooler that I was working with. So rest assured, when you see this build, this is not, he just tossed it together. This is, I put a lot of different parts into this machine. I tried a lot of different setups, and this is the one that I found to be most reliable, most optimized, worked really, really well for thermals, and it is just absolutely kicking butt. And last but not least for thermals, of course, these 2 GPUs are spaced out as wide as they can be on the PCIe bus. So one's in slot 1, one's in slot 7, and they've got maximum space between them, so that fan wall can kind of blow between them and introduce air between those different gaps. This stuff obviously gets a lot more complicated when you start packing more and more of them tightly together. But right now, this entire thing is non-power throttled. It rejects BTUs like an absolute champ. There's no risks of water or leaks or pump failures or things like that. It's just absolutely, absolutely kicking butt. So that's our setup. That's what we currently have for thermals. And that's the video. Thanks.